All right, there we go. The recording has been started. Welcome, everybody. Does anybody have any updates or news they want to share? Anything they figured out before we kick off Lauren and her topic for tonight? Is everyone feeling like they've got their robot design figured out? Nobody wants to talk about prototyping until we get to our topic. All right, well then with that, let's turn it over to Lauren. Lauren's from Fire Bears, and she's going to talk to us about strategic design, or strategic, is it design or prototyping? Strategic design that meets the capabilities of your team. Yes, I got it right. All right, Lauren, the floor is yours. Take it away.
Hi. So tonight I kind of broke my questions and discussion topics up into two main categories. One's that are season specific and ways to make your robot more just better and more fit a good strategy for this season versus just general stuff that works for every season. And the first topic I wanted to go over was, what do you guys think is more important, or what did you guys prioritize between the amp and the speaker? Or did you guys choose to do both? And should the higher level teams be choosing to do both or not?
I will start. We are planning to do everything. We, for our team, for our robot, and this is not something that should be the same for all teams, but for our team, our robot, we put speaker and then trap and then amp for Duluth, because we feel like for week one, the best chance of getting a ranking point is if you can score in the trap. And then we reversed those for 10K because we felt like there'd be a better chance other teams would be able to score in the trap for 10K. So if we end up redesigning our mechanisms, our priorities will change for week 5. I think 10K is week 5.
I guess I'll go. Yeah, generally, kind of feel like amp's more important for kind of deep playoff runs when everybody's kind of coordinating on the power amplification, I believe it's called. Yeah. And other than that, pretty much speaker over it generally. That's kind of how we're feeling anyway.
I'll go, I guess. For both of our teams, I think game piece acquisition, getting our intakes and stuff working is our first priority, and it usually is. Being able to shoot to the speaker is definitely important. I think that falls a little bit ahead of the amp, which I realize is also very important, but trying to design a mechanism that can do both relatively well. Climbing doesn't scare me. The trap is not even on our radar at the moment.
Yeah, I was talking to this Scott and I think Jesse earlier. The trap is not even on our radar right now because it's just, we're probably going to wait until Granite City and see what other teams have done, watching and be like, oh, hey, maybe we can add that, or maybe we just stick with what we're doing. I think as a relatively young team, our amplification and ground pickup, because when you look at all the obstructions in the way, we don't have the programming capability to do all these very limelight things to make sure your robot lines up at a human player station. And so since we figure amplification is our main target, pick up those game pieces, and even when you go on the other side, it can also just fall on the floor and you pick it up and come right back and amplify. And so, and like Jesse said, well, the good thing with this game is that the climbing mechanism does not involve anything foreign that anyone have to do anything crazy. Just try not to slide off that chain. and bump into another robot, and then both of you end up falling off or something like that. But besides that, we'll see how week 2 goes, because we're going to week 2 in Granite City. So hopefully we pick up something along the way.
For us
And
this year,
one more thing though, and I will throw this out there. What do you guys think? It's like, because any team going for amplification, if you can do a double auto in the amp, right, and then have those other shoot it all in the speaker people have an auto and a game piece ready, I think that might just be a good seller point too for those amplification teams.
yeah. As far as our team goes, we this year decided to prioritize the speaker, but also heavily prioritize the amp as well. Really, just both of them to do well, we realized require a fast cycle time, and then we just make a mechanism that can do both. As long as we have fast cycle time, we feasibly should be a very good team. So, and then also as far as the track goes, it's basically, we see it as something that helps you get up in the rankings, but as far as playoffs go, it's not going to get you very far. It doesn't, because the amount of time to get up there, climb, and score it, you could probably get another cycle or two in the speaker or amp, which would most likely get you more points than the trap.
All right. Another strategy is actually in this, like you said, I learned it might work for all season too, and we decided with our mechanism that we kind of go with what we learned in our last 2 years within a team, and then implement those to give us a robot probably in a much faster time, so we can have better driving experiences, because we've always showed up with a robot, but the kids haven't really driven it. And so then you get there, your first initial matches are your practice matches, which kind of sucks, because at that point you shouldn't be practicing, you should be qualifying. And so implementing what we already learned to get us a fast turnaround for a robot, I think might serve better than trying to, do more complicated things that might end up causing more problems.
Another topic I wanted to discuss was then for intakes. Are you guys prioritizing like a ground intake over a source intake? And if you're doing a ground intake, do you believe over the bumper or under the bumper is better?
Well, actually, I always stress to the team, basically, if it sticks out there, I've seen it for many years, it's going to get smacked. So they're working on a system now that is under the bumper, tucked away to where there'll be minimal damage to their intakes. So that's the direction they're heading at this point. So I've seen it so many times. You have something out there, especially with two big objects in the middle of the field. The vision for the drivers aren't going to be spectacular. It's going to be another, what was that, Steamworks, where they had the two big towers, where I actually saw a head-on collision where he ejected a battery about 10 feet in the air. It was pretty brutal. So I showed them a little clip of that, and they're like, oh yeah, under the bumper, under the chassis, let's tuck it away, keep it out of harm's way.
Yeah. On the vision sightlines, I was one of the drivers on a team in 2017. And so I know how hard it was to look around those airships, but there was pretty good sight lines from most of the driver stations to the pickup station and to your placement zones. And I think this year it's not going to be as bad because the stage doesn't look like it impedes as much of your vision. It's still not going to be great. There was times where I would get stuck behind the opponent's airship and I'd have to go look down at our camera view. But most of the time I didn't have to.
Yeah, you know, we one of the initial RIE robot in 3 days video that I saw was doing the under the bumper, and then one of my kids like, no, we cannot do that. What if it gets stuck? And they all panic about it. And so, but then you know what? They would prefer over the bumper. And well, I told them if we're gonna do over the bumper, we're gonna have to build it close to the bumper so that when we hit something, some of that shock will go into the bumper. But also be ready to make duplicates that you can you can swap out like at a NASCAR speed, like put it back on in within 10 minutes because that's pretty much the time you may have to do that. And so, and then I think I was talking with Scott earlier. One of the things we kind of want to do is put something like a photo, like a bin, break that when you acquire a game piece, it will be an auto response if your intake and put it within a parameter of your robot, so that you know that would be one protective mechanism too. I know it add another layer to when you're ready to score it, but you would still have your game piece, and then you will also have your robot intact too. So
Yeah, we were worried about the external over the bumper intake for the same reasons, thinking that it's going to get smacked. And auto is, a big concern is what happens in auto with, like you were saying, with all of the some of the robots going toward the center to try to get those notes in the center. Maybe that's why there's an A stop this year. Maybe that's one of the reasons. But we are prioritizing the over the bumper one because we're not sure if we are how capable we are of doing an internal intake and making good use of the real estate on a robot. That remains after that. So that's where we are right now, but we have the other things in the back of our mind.
I think with the exception of auto, I mean, having an over the bumper intake this year isn't any different than any other year, really. I mean, and teams have been running over the bumper intakes forever. So I don't see that as a huge disadvantage. We got one team that's kind of leaning towards that right now, and we have a different team that I'm working with that is leaning towards underneath the robot intake. So I think both are pretty viable. I mean, there's going to be collisions like there always has been, and if you build it robust or replaceable, then you're probably okay.
Our team is our first prototype, we're hoping to make it work as an under the bumper intake. But we also have students in CAD working on over the bumper options as well.
On Chief Delphi, Team 95 posted under the bumper intake that's outside of the swerve modules. So their swerve base is about 24 inches long, and then they imagine the swerve being a little longer, like almost like a pickup truck, dump truck, or the bed of a pickup truck kind of sticking off the end. And that's where the intake is. We haven't started prototyping an intake yet, but we're gonna start this week. But we're leaning towards under the bumper as well for protection sort of things, but not decided yet.
We are going with over the bumper intake. We kind of decided through mini trials how that same kind of like very similar human player station where you can drop it and either the robot can receive straight from there or it can receive from the floor. We in the past have made our extending pieces on our robot purposely so that they can take in damage. Our 2022 bot had an external intake, and that was also the shooter. It had churros protecting the actual flywheels, and it was originally made out of steel, but it was very heavy. But it was meant to take in all that damage. Last year, we made plates on our mechanism so that it could bend. And the only thing that would bend would be those plates and not our actual moving mechanisms. So I feel pretty confident that our team is going to be able to make something that can withstand the damage like we have in the past.
I guess one of the,
Go ahead, Sam.
all right. I was saying one of the things people or teams should think about is, this year you can't pull it through your bumper, or you can't do a bumper gap even. So in the past, and you pretty much have to go down to the floor. So you kind of got this double thing of like you can't go through your bumper and you have to go through the floor. And if you look at the lever arms to make that happen, the damage is going to be just worse than it's been in the past. I mean, I think uniquely this year, the damage that you're going to have to be able to withhold or how durable it's going to have to be is going to be higher than previous years. But just something to think about. I don't know.
We're doing over the bumper 4-bar cutting plates right now, actually, and it'll be fine like every other year. A lot of debate between over the bumper, under the bumper. It'll be a more violent game than normal. Everybody's going to be gearing as fast as they can. It's a wide open field. Going to get crashed into. If you're building an out of the bumper intake, be ready for it to get crashed into. And if you do that, you're fine. I don't think there's a huge reason to do one or the other if you implement it well. So that's where we're at.
Another reason why we're choosing to do over the bumper is you get a lot more contact area than if you did under the bumper, which was a large kind of thing that you have to worry about. It makes it a lot easier to pick up pieces, especially if you're doing top and bottom rollers. It just makes it a lot easier for drivers to be able to maneuver around if there's a larger contact area for those pieces.
For the next topic, I was basically, where are you rating the importance of going under this stage? Do you find it that valuable or not?
I will say for KnightKrawler, it's our number one design constraint.
Same for Jets.
That was one of the reasons why we also like this intake shooter mechanism, combining our prior experiences. Is in case push comes to shove and you need to wiggle your way out of there with a swerve module, you can just ride under that. And as a support bot, getting cycles, getting as many notes in as possible in the amplifier is key. And so if we can find a route here that's not direct but faster, hopefully that will pay off.
Yeah, we found it pretty important because, well, otherwise you have to go around the stage, and that's just going to add a lot of cycle time to just increase your time in your cycles. Because this year you should be able to have an intake that it almost instantly picks up the note, so there won't be a lot of time there. So then your next two most time constraints, or like time places you're going to sink all of your cycle time into, is going to be your movement, and then like lining up to the score in the amp or the speaker. So if we can reduce one of those by going under the stage, we thought it would be really helpful, and then also allows for you to be a very flexible team in terms of like pathing, because all three robots can't be trying to do the exact same path to score. So if you can move around and be able to do basically any option, that's going to make you a lot more of a valuable team and work with a lot more robots.
I think one of the things you'll like when you start digging into the design of it is having being lower to the ground where you shoot from makes the shot easier from further away. And so it's one of those things where you kind of get, if you go below the stage, you kind of get the double benefit of the shots easier. And so I think kind of makes it pretty attractive to do both. It's the first kind of high shooting game in a while where it's made the shot almost easier if you're lower. If you think back in the 2020 game or the 2022 game, an advantage to be taller, just less distance to go. But now with this, kind of goofy shot angle, low release is important. So yeah.
More thoughts about shooting. I don't think the safe zone from shooting from the podium is going to be really all that safe, because I think, well, if you're a short bot, which it sounds like a lot of people are thinking short bot, just about any other block will be able to block you. Will be able to block your shooter. So I don't think the podium is going to be all that safe of a safe place to be when you're shooting. So I think being maneuverable is going to be more important, since everyone's going to be so short.
But I think the main advantage of the podium is not so much that you will gain so much points, but might be because that penalty point will work against the other side more so. And, I don't know.
Yeah, I wasn't thinking that. I mean, I think people won't bump you when you're at the podium, but I also think it doesn't take a very tall robot to block somebody who's at the podium, especially if you have a climber. Just stick those arms up and they'll hit you.
Okay, like an NBA.
And then the podium, another kind of problem we notice with it is you have to go around and basically slow down to be able to touch it. And it's just, you're going to add a lot more time by going to the podium versus just like ramming the subwoofer or something, because you have to slow down and try to get in a precise spot, because the podium, it's not like super big. It's about like, I think the size of the launch pad in 2022. So it'll be it's kind of hard to like just get there and stay there, which means you have to really just slow down to get there, which is just going to make your cycles a lot longer.
I think an unfortunate part of this year's game with shooting is that first put the April tags so low. So if you build a robot that aims by using the April tags, almost any robot can block the April tag, because the April tag's so much lower than the goal. If we were still using retroflective tape, I'm sure the tape would have been around the goal or maybe under the goal. It would have been so much better for an aiming facility. But since they put the April tag so low rather than putting it above the goal, it's an unfortunate side effect of moving away from reflective tape.
So I've been in and out. I may have missed the conversation, but if people talked about top and bottom rollers versus side rollers for shooters, anybody prototyped anything? Anybody liked anything? I'm curious to hear kind of the general consensus on what direction people are going.
Appears that our team is leaning towards the top and bottom type shooter. They seem to be able to get a more consistent throw out of it, believe it or not, as long as the wheels are placed correctly when they're building it. You try to squish those rings down, they want a tendency of going off a little wonky sometimes.
So with our prototype of the intake shooter mechanisms, we figured that if you have at least 4 inches of 4-inch wheels, that I think having something that has less grip on it is actually better. Like if you're gonna use a pneumatic wheel, like not the one with all the bumps, but 3 on top, 3 on the bottom seems to be a good contact point to get that ring flying.
With the now scarcity of our notes, has anyone had one of their notes meet the unfortunate demise where it's been run over or broken, such that they now are going to have to, tape it together, then fire it through their shooter and see how that may work compared to, with rollers on top and bottom versus now requiring that hoop strength?
Here's the thing, taping it together doesn't work whatsoever. I left practice, my other mentors were there. I come back to practice. One of our precious notes was ripped in half. We've tried a lot of different things to, glue it back together, tape it back together. Pretty much anytime you fire it, both with side rollers and with over-under rollers, you're not going to get it to fly the same. And in the case of over-under rollers, the tape kept coming undone. So if you break a note, it's pretty much worthless to you except for maybe intaking, but you can't really shoot it.
So we actually, since we were able to obtain more notes, we got a little daring and intentionally drove over a note to see if our swerve wheels would tear it up. We have the Rev swerve modules, and it does make little marks in it from if you drive over it a couple times, but it didn't do major damage to it, and it also didn't hang up our robot. So we're able to drive on and off a note without it getting wrapped around our swerve modules and stuck under the robot.
Yeah, if you go to our Open Alliance thread, you'll see some videos that we posted yesterday of our 2023 robot driving over them just fine. So I don't think we're going to have problems getting them stuck under robots.
Yeah, we also discovered our 2023 robot intake, which is the EveryBot 3 roller with the 2-inch compliant wheels will actually intake the note. It's a little tight, but it will actually suck it in. It spits it all the way through. It's hard to stop it halfway through, but it will actually handle a note with the compliant wheel 2 roller design that we used for the cones from last year. So we know that some of the same concepts that we've used in past years seem to work fairly well with the notes.
Got a question here about that. So with that, I think the foam is about 2-inch, depth. So if you drop your bumper down to 1-inch, just so that, especially with over the bumper intake, the first contact it goes in, or if it's off on the side, it just roll around. So technically you're not in possession of it,
You are, but you're controlling the note. If it's underneath your robot,
Yeah.
and you drive and you're dragging it with you, you are controlling it, which
that's what I'm
prevents
saying.
you from controlling a second note.
That's subjective based on whatever the referee closest to you sees. Oftentimes that won't get called. Sometimes doing something not as egregious will get called. It's a total crapshoot.
So,
But the rules state you can't control 2 notes, and that's controlling a note. So the fact that not all refs call it doesn't make it a legal move. So if you want to design your robot to do something that violates the rule, that's your risk. But what we found is keeping the bumpers higher allows you to drive off the robot and not trap the note underneath it. So that works better for us.
If your wheel is inside of a note, I'm 100% confident that you will be equally, liable of controlling that note as somebody pushing it with their bumper.
So
it will be looked at no differently.
Ryan, what we actually found is at least with the Rev modules, you're able to just drive out of a note, no problem. So we're planning on keeping our bumpers at a normal height with, 2 inches of ground clearance, and we'll just drive over notes. We're not going to worry about pushing them out of the way or trying to get them to not go under lower bumpers, because then we run the risk of it's stuck under there, and then we're stuck.
People are for sure going to get beached on these things. I watched your video. I thought it was awesome. Really appreciate you guys doing that test. Did you drive over them like twice, or did you drive over them a bunch of different times? And did you ever get stuck?
We let our driver just go ham on it, and we didn't get stuck. I mean, slow tests, it just kind of bops over it. Fast tests, it just flies over them.
Sweet. Oh, that's good to know.
Yep.
Yeah. The risk is, say you set it at 1 inch, and most of the time you're going to plow the note. But if it's up against a wall and you drive over it and then your wheel gets over the top of the note, with the low bumpers, you may not be able to get it back off because you can't use a wall to get it out of your bot, but a wall might push it into your bot. Now, if you had them, a 1/4 inch off the carpet, you may never get one. But for us, since it's so easy to drive off them, why bother trying to set it up so that you can't get them underneath when it's a non-issue if they do get underneath?
Yeah, and for No Mythic, we completely inverted our serve modules because we're using the Mark IV inverted, but we uninverted them and put the frame on top. So we have 4 inches of clearance. Granted, some of that will be taken away by bumpers, so we put that on, but with those as well, it works completely fine.
Yeah, I mean, your bumpers are going to be a maximum of 2 inches off the ground because your bumper zone is ground to 7.5 inches. And since your bumpers have a minimum of 5 inches of plywood, the most ground clearance for your bumpers, I don't care about your frame or your wheels, is 2 inches.
Don, it's actually 3 inches because the bumper zone is up to 7.5, and the bumper wood is 5 plus minus a half inch.
So if you want to go skinny bumpers and go 4.5 inch plywood, but still the noodles, and you're going the slim side and the noodles plus fabric, so you could be 5 1/4, but yeah, you're not going to get 4 inches of ground clearance with
No, you get 0 to 3 is your rule.
But the note's only 2 inches tall, so as long as you're 2 inches, you're good probably.
How are you guys building your bumpers so that your bumpers don't sag halfway through a match or halfway through the season and you drop down a half an inch or more because your fabric gets stretched or your noodles get smaller because they take so many impacts? If you start with it being only 2 inches off the ground and then you deal with a half-inch sag, now you're trapping noodles underneath your bumpers.
We've never really experienced that sag that you have, Scott. So I don't know what we're doing different than you all. I mean, I tend to put a knee on the bumper wood and squish the pool noodles as I'm applying the fabric and let it stretch back after.
And we also do put some duct tape, just a couple loops. We don't do the whole thing, but we put a couple loops on to tape the noodles to the wood before we cover the fabric. We use really tough fabric. The fabric's really well. So we were testing this with our 2023 bot, which had 2 regionals plus state plus 3 off-season events. So these are worn bumpers. Actually, that's right. It's our swerve bumpers. So they went through 3 off-season events and lots of practice. They didn't. I forgot. We switched bases. We went from tank to swerve during the off-season, but they still have a lot of patches on them. And so yeah, they're maybe 1 3/4 inches. But the note just kind of squishes and you just drive over it. I think if your bumper is at least 1.5 inches, you'll drive over it.
Yeah, Scott. It also may depend on what type of fabric you have on your bumpers. I know a lot of the smoother fabrics tend to stretch out a little bit more than your 1000D Cordura that the rules recommend that Andy Mark sells. That stuff tends to be a lot better at holding its shape.
Yeah, and anecdotally, we use the Andy Mark provided 1000D Cordura, right? So that kind of supports what John's saying. I haven't seen that much stretch in it. Then again, we don't play as many matches as you do, Scott. So take it with a grain of salt.
Yeah, Scott. So this is Tracy on Firebears. The last couple of years, to combat that sag, we use the Gorilla double-sided tape, and the pool noodles are hooked together with that, and they're like welded. You can't pull them apart without ripping them. And then we stick that double-sided tape on the wood as well, and as long as the fabric is tight, they don't move at all. It's a lot of double-sided tape, but that Gorilla double-sided tape is almost like super glue for the foam pool noodles.
Well, also be aware of, we just ran into this. We ordered a whole box of noodles from Walmart. Said they were 2.5 inches. I just took a tape measure and I'm going, no way, they're more of a 2 1/8, which we shouldn't be using. So be aware of actually how thick your noodles are coming in, because their advertisement's a little off.
Yeah, I think this year's rules are written to be a little more lenient with that inevitable variability where manufacturers are making them a smaller diameter, and also it seems like the inner hole, if it is a hollow, seems to get larger. So just trying to make a same noodle with less material.
Yeah, the rules actually 2 1/8 to 2 3/4. So the 2 1/8 actually are legal, maybe not recommended, with how stringent, especially with the way our driver drives. She slams into people pretty hard.
Yeah.
If you're on the field with us, you probably want thicker ones.
It's actually not the impacts that we're looking at. It is actually creates a kind of a wedge look to the front of the bumper. So if you do end up coming into something, you could actually, wedge, just because you got to spread those noodles a little bit better. I was talking to kids.
They don't cover the plywood as well.
Right, exactly. You end up with this sort of almost wedge type bumper to it. And if it's at the bottom or the top, things could skip up, skip down because one noodle's compressing. I was looking at it going, oh, this is not going to be a good scene. We're going to have to do something about this. So that's just us, though.
If people are still looking for noodles, there's a place in Chanhassen that produces pool noodles called foamnoodles.com, and they sell a variety of them. You can find them on Amazon too, but we tend to pick them up there and save the shipping cost.
We buy the oodles and noodles, solid noodles, so they're actually 2.5 inches, which makes our bumpers bigger. So because our noodles are actual 5.5, if you're working with noodles that are more like combined 4.25, then they're going to be pinched together on the board, and so maybe less likely to sag. But if your noodles are 5 and your board is 5, then you can see some drop, which might be part of the reason why you're seeing drop is because you're using really big, sturdy noodles.
And Scott, that's the same manufacturer from Chanhassen.
Who would ever thought pool noodles might be an issue someday?
I am looking at. Oops, sorry.
I was going to ask Jason how much they run you a piece. I think ours are like $6 on Amazon.
I think about the same. If you call and talk them up, you can usually get them to bring it down, but it ends up being like $5-6 a pool noodle. So
I was just going to say too, just looking at the rules, 408C, the blue box does state that 2.5 are sold as 2.5 inch, or that measure between 2 1/8 and 2 3/4. So they are more lenient this year on the range of noodles.
Can that company start making some notes for us, please? If anybody knows anybody there.
It's different foam. Different foam.
I know. I was joking. Sorry. I was trying to make a joke.
Oh, you're good.
So with being on a team, a KnightKrawler that we're considering, being short as a priority to fit underneath the core, having, ground clearance, if you're having, so you can drive over the bumper, over the noodle. So a 2-inch, let's say, bumper height and gap. And let's say you want to make it your belly pan as well. Does that, and looking at that, we're trying to tackle the trap, is that concern of that extra height of CG or even bumper height going to create that difficulty pulling that chain down to the bottom of your robot?
Well, that was just the thing that we just finished Saturday, getting that chain set up, and we kind of stared at it and said, huh, that center's pretty darn short. That's pretty low. So it's going to be a project that the kids are going to have to figure out with the rest of the robot on how to clear all that. It's pretty low, though, if you've ever seen it in real life. Looks so tiny on the little screen, but now you put it in real life, it's like, terrible.
Yeah, I concur, Greg. We got our stage set up, and that chain looks very low. Yes, I agree.
Yeah, I mean, if you're looking just to get your robot off the ground, it doesn't seem such a daunting task, but then trying to, figure out how to elevate your robot to be able to score in that trap and what that means for the overall 48-inch robot minus, that difference, having to figure out how far that chain has to come down into your robot's vertical size.
And it'll have to be pretty darn balanced because you're not going to be that far off the ground.
Something that when we started looking at the chain, sorry, Lauren, are we digging too far deep into your presentation? Maybe we should wait until you get to the stage. What do you want to do?
I'm fine with this because the rest of my topics were completely not related to the Crescendo game. So
okay,
this is fine.
So one of the things that we had talked about doing for the balance that you talked about, Greg, is maybe we just need a little bit wider hook and just one in the middle so that you are hanging balanced. Because if you have two arms, this came up with a call last week, and you're on the side of the chain you start to pull, one might start taking pressure and the other one might be totally free. And then your partner robot swings the chain away, and now this one doesn't grab the chain at all, and you're lifting on one hook. So we started thinking about that, and we discovered that if you put one arm in the center of the chain and you pull, the chain goes down 3 more inches. But if you have 2 arms and they're about 2 feet apart, then it's about the same distance. It stays at about that 28 inches off the floor. So suddenly the idea of one arm is going to be better because you only have to grab it once. You don't have to grab it twice. Now you have to pick yourself up 3 extra inches off the ground, which was not something that we thought about until we actually had our stage and started messing around with the chain.
Yeah, and I think to add on to that as well, because for No Mythic, we just went over the discussion of 1 or 2 arms, and we decided on 2. But one of the arguments for a 1-arm climb was that you can use the truss, and so you can be way over at the edge, and then just climb with 1 arm on the edge and use the truss as sort of your guiding. Because especially if you're trying to get the ensemble ranking point, being able to fit 2 or even 3 robots on that chain could be very helpful.
That's actually one of the questions I was going to ask is anyone thinking about this crazy idea of trying to fit 3 robots, and what design strategies people are trying to implement to see if, push down the shelf to fit 3 robots on one chain? Is it worth the risk?
Hey, Scott, we haven't got our stage built. What's the distance between the posts? Not the length of the chain, but the distance between the posts.
I can bring up the CAD and get that for you.
Okay, yeah,
I'll do that
hard to
while
tell.
everybody can chat about Jeremiah's question of hanging 3. I will say that I don't think we'll see that except for in maybe finals.
Okay. Yeah.
That's my opinion.
I will say our bot, the way we designed it is we're going with a very small chassis. It's going to be 21 by 28. And so for us, doing a 3-bot climb probably wouldn't be too hard because we're so small that there's a lot more room for other people. But yeah, it's not something that you would necessarily see in like qualification matches, because unless you really, really need that, it's much easier to just do 2 on one chain, and then if 3 can climb, then someone just goes on another chain. But in playoffs, it could easily be the deciding factor on who wins the match. So you would probably see it there as well.
Well, then one of the other big advantages of having 3 robots on the same chain is now you get 3 chances for that high note on one microphone rather than trying to make 3 different ones. Now, is that going to make a big difference, or what's the reliability of that? I don't know, but you go from getting that bonus point. You got to go 1 for 3 to get the bonus point for your whole alliance versus trying to go 3 for 3, or I'm sure we'll see plenty of 0 for 3s most matches, but we'll see.
And that was the other thing, Sam, because if you have those 3, you have 3 chances of getting at least 1 in there. And so, but if we have big fat robots trying to maintain center of gravity, that becomes another thing. So it'd be really interesting to see what Scott finds out with his with their CAD.
I mean, I gotta say, despite kind of like sounding like I'm advocating for that, really, I think we're kind of leaning towards make the overall design easier, and cycle 1 more time. Just I think that's I don't know. Really depends on your team's resources, like everything. But
I have another question, actually, if you guys don't, thanks by the way for the responses. So have anyone found a way to do a handoff intake for the kit bot?
We haven't tested it out. We just finished our kit bot on Saturday, and we finished it at 4:59, and we were leaving at 5 p.m. So we couldn't actually shoot any notes. But I think the Cranberry Alarm RI3D team has the from what I could see on the kit bot, the most elegant solution to to that where they cut out just part of the polycarb, and then it flips. If you do the geometry right, it can flip up into the intake and just go. I would look at Cranberry Alarm if I was talking to a team who had the kit bot and that was going to be their bot and they weren't going to do anything else. Floor pickup would be my first suggestion, and then my second would be buying some climber arms from Andy Mark or Rev and slapping those on. And I think you'd have a pretty darn good robot.
What's about a modification for the amplifier for that? Because you know, you need to have something. you will need to have something to dampen. You know, because you can't shoot into that with those flywheels and have it score. You have to dampen that a little bit to because it will kick it back to the robot. So if you have something to, keep it in play, and then it will slide back down. I saw one guy out of Pennsylvania who did something similar with a flap with a polycarbon flap that, when you jerk the robot, then the flap opens, and then when he backs up and shoots, and then they come back, and then it just slides right in there. But I don't know how reliable that is. I haven't tried it yet.
To answer the question that Tracy posed, it's about 100 inches, give or take, half an inch or so, which is what the field tolerance will be anyway. But from hook to hook, it's about 100 inches.
Thanks, Scott. Yeah, it was just hard to tell in that. So, yeah, you'll have to have pretty narrow. If you have one narrow robot, it becomes doable. But then you have to have climbers that go up higher if you're going to be not in the center.
The other thing I want to bring up about the climbing is that the chain, like a normal hook design, that can just slide very easily. So something we looked into was if there's a way to sort of grab a spot on the chain and stay there, which we've seen some solutions online and we've tested some. But I think that'll be something that would be very important if you're looking for multiple robots.
I've heard that come up a couple of different times, but all log chains, typically when you buy a log chain, it has hooks on the ends that slot into a link. And so you should, if you design your climber hooks to have that same slot that you have on a typical log chain, the end hook, that should allow you to slide until you kind of link into a link. That's not probably lock into a link. And that will probably help you avoid your slide. If that's your goal, is to not be able to slide at all. You can probably design your hooks and then CNC or even use a hacksaw and cut out a slot that matches the link diameter plus or minus some slop.
And we prototyped that, and it seems to work pretty well. So I agree. I think that seems like a solid way to do it.
So if everyone's kind of done talking about season-specific topics and stuff, I have some questions more related to general robot design, if people want to move on. Okay. The first one is about what design ideas and what techniques and stuff do you use to make your robot more reliable? Break less and just be consistent throughout matches?
Keep it simple.
Protect anything fragile, your hoses, your wires, protect all of that stuff behind polycarb. Get it nicely secured with zip ties, strain relief, things like that.
Bring a hot glue gun. Hot glue your battery cable. I laugh. That did cost us a playoff match during one of our off seasons.
Stay away from Wagos for can wiring. All those things drive me nuts.
Now, oddly enough, that conversation we had a few months ago about CAN wires, man, that discussion got pretty heated. Everybody had an opinion on how to do your CAN wires. But there's a lot to be said about that. That if I'll have to go back and see what conversation that was, but there was some really, really great advice in there. That was the talk that Talon, I think Talon had a talk about what makes good wiring. And they were asking, please tell us what makes good wiring, because they had 2 out of 12 matches or something like that where they had a wiring issue. And so there was a great discussion there on building reliable robots by having good wiring.
Well, we've had a lot of improvement on Talon. You need to use ferrules in your Wagos. Don't use strip wires. They'll pull right out.
Wait, so when you say Wago, Eric, so Wago is a brand that encompasses a number of different products.
He's talking about crimp nuts, right? It's got the lever nuts.
The
lever
lever
nuts.
ones, yeah, I don't have them in front of me.
It makes it quick and easy to do the CAN wiring on Nightmare when it starts bouncing around and hitting things.
But if you put a ferrule in, you can pull them out.
And you should borrow Jeremiah's hot glue gun and hot glue them to your frame someplace so they can't flop around.
Or, you can just be mean and say, hey, kids, don't use them.
They need to be secured down. They do have a non-zero mass. And so when you're driving around the field and it's swinging around, that's going to take its toll on that, 22 gauge wire.
Yep.
Yeah, for us, probably we think one of the biggest ways of keeping your robot reliable is don't try to overextend beyond what your team can accomplish. If you know, like this year, if you know you can't do the trap, don't try to do it. If you know it would be a stretch, you're probably going to have a robot that can do it, but it's going to probably break a lot, not be very consistent. And well, if you're not very consistent, you're probably not very good as a playoff choice, because playoffs are all about being consistently good.
I think that's a very good point, because something that I think that we ran into last year was making sure that you have the time to complete all your systems and test them. Because last year we went with an ARM design, and I guess this is a little bit more specific, but I think something we noticed there was that there were still a few things that we needed to work out in the competition, which we did, and it was a lot of fun. But I think making sure that you have the time to complete everything is also really important.
I will make the comment that teams need to invest in their programmers. And what I mean by that is have more than one or more than zero training in the fall, and get your robot to your programmers early so they can test it, but they can build safeties into the system so that they don't run an arm past its limits or run an elevator past its limits. They can write, they can get enough time on the robot to verify their code does what it wants to do. And then you start adding the safety checks and the extra code in there to make sure it doesn't do what it's not supposed to do. I think a lot of teams hand their robot off to their programmers in the last couple of days before a competition. And I think a lot of what happens at competitions that break could have been avoided or solved with more time with code. And teams just don't ever a lot of teams don't make that a priority in their schedule, or they're willing to let their schedule slip. And the programmers are the ones that pay that price.
Yeah. Also, please set current limits on all your motors. It's never a fun day when you find out that you burned out your fancy new brushless motor because you left it at, the default current limit, or that your arm was stuck driving full speed and now your motor's burned up, or it breaks something. What I tell all the programmers is set as low of a current limit as you feel like will probably make it work. And then if we end up having problems, increase it a little bit. But leave it low, then your motors don't have enough power to completely destroy things. Once you've got those safeties in place, maybe you can pull that back, but that's just a quick and easy way to make sure things don't get broken.
I think someone had their hand up, but I just joined the conversation, but I totally agree. Getting something to your programmers right away is incredibly valuable. What we're trying to do this year is do like what we call an alpha robot, where you ship a CAD as early as you can, cut everything out, get everything bolted on a swerve base, whether it's an old one or a new one. In our case, we're going to be building a new one because we don't have anything that would match up with the frame perimeter requirements we need. But the goal is really by the end of the week, or at worst end of the following week, have an intake, a shooter with a variable angle, and indexer, basically the full ring path for a speaker shot, with the goal being, hey, here you go, programmers, you've got everything you need to do in order to create auto paths, in order to test vision, automation, stuff like that. The alpha robot we're building, it'll look a little bit like our final robot. It'll be simplified. It won't have any kind of trap mechanism on it, but it'll be a tool for our programmers to use and get ready for the real robot, if you will.
I like that you call it your alpha robot. Actually, I told the kids, I said, as a new team, we have these great ideas and we get lost in them, and then we find ourselves with our final idea where we end up like fixing, sticking things here and there, and then you end up with this mixed up that didn't really belong there, but that's where we can shove it to make it work. So we bought 2 swerve modules and said, hey, you know what? Fortunately, one of our sponsors gave us some aluminum. Like, hey, let's build a robot for week 0 that then we can go test all the limits and whatever we can shove here and there, and and then come back and disassemble that and build our actual and that has to do with also having something to program too early on set before we go to competition. So hopefully that pays off. I'm hoping that we meet our timeline. I'm really hoping that's our biggest strategy, is the timeline, sticking to it.
I had something to say about burning out your motors and such. Often what happens is you don't burn them out during competition, you're burning them out during practice. So that's something to be aware of, because a competition is only 2.5 minutes. We burn them out because a practice can go for an hour and the motors aren't made to run continuous there, but 2.5 minutes isn't enough to burn the motors out. Just a heads up as to where you might be losing your motors.
Go ahead, Tom, jump in.
I think you're still muted.
It's still muted. You'll have to, I don't know.
Oftentimes you need to allow Google to have access to your mic, or use oftentimes a keyboard button that mutes your mic too. Just double check those couple things.
You get it worked out, Tom. Just jump in whenever you get it worked out.
Yeah, we were discussing this year on getting the robot to the programming team with lots of time, right, to give their time to work with it. And so we were discussing it not as much from a competition lens of maximizing performance, but from a respect lens, that not everyone on the team is most excited or has the most to deliver in each of the phases, right? And so some people, the prototyping phase is where they're really going to shine, right? For some people, it's during the troubleshooting phase. For some people, it's at competition. For some people, it's not even on the robot, right? And so if we continue to front load or utilize most of the schedule for the first portion, right, of analyzing the game, designing the robot, finally building the robot, right, and don't leave time for all those other aspects of the schedule, you're essentially showing that you don't respect what other people are contributing, right? And so I think that framing has been good for all of the people on our team to think about it from that lens of like, look, yeah, you might be really interested in the design phase and you keep thinking that there's one more thing you could add if you just had a little bit more time, right? You can make this robot so much better, but other people have ways to contribute that are different than you, and you have to give them the room to do that.
So, sorry, I missed that, Jason, but the thing I wanted to check, whether it's Scott or Lauren or anybody, how much, since you mentioned the programming time, and I think that's really, really critical. Well, everything is, but would anybody, either you two or anybody else, care to comment on the use of a Romy or some other methodology where build and programming are going to work in parallel? I realize some of what you said couldn't happen that way, but anyhow, I'm off.
As someone who has invested well over 100 hours trying to build Romy training for our team this year, starting in my August turned into my August project to try to build programming training around the Romy turned into my August, September, October, November project. The Romy is not a good analog for teaching your programmers programming. And the reason why I say that is if you go out on the internet and you search YouTube, you search Google, you do whatever you want to, wherever you want to go to try to find Romy programming training, the only thing you're going to find, and I know this because I spent lots of hours doing this, is teaching your programmers how to drive the Romy. And
forgive me if I can jump in. No, not for training, but for programming when the robot is unavailable, for testing a number of things. That's the part I wanted to ask about.
Okay,
sorry.
So that's where I'm taking a long path to get to that answer. The Romy can't do pneumatics. The only motor controllers it can do is the Jaguars and the Talons that are PWM. And so you can't buy, it's called anti-phase locking PWM signal. And so you can't buy a $3, a $4, $5 motor controller on Amazon that would actually fit on a Romy small chassis. And unless your robot uses a servo, which I don't know how many people have put a servo on their robot in recent history, you're not going to find a reasonable analog to what you're going to do with a real robot. I'm trying to find a way that you can build subsystems using analog input or analog input, digital DIO, to drive simple motor controllers like 100% on, 100% off. And I've been able to do that, but that's not going to teach kids how to build a subclass for a mechanism. With a little bit of work and a lot of knowledge, you can get kids so that you can build subsystems and commands, and you can teach them command-based programming that way. And then maybe you can put together some autos, but it's not a free thing. And you're not going to find anything on the internet that'll show you how to do that, because there isn't one, and I'm not done with my training yet. So unfortunately, the Romy, I personally don't think, after spending a lot of hours on it, the Romy is a good analog for giving kids any way to test their code or even to learn how they might pull something together in a system. The other thing the Romy has is you only have 5 outputs. You can only control 5 things on your robot. And so that sounds like a lot until you realize that, if you want to run a motor using a simple motor controller, that takes up 2, one to go forward, one to reverse. And that really cuts down the number of little motors you could put on there to teach kids how to run a subsystem or build a subsystem. It's really frustrating, I will say.
So you're saying let LED outputs as indicators of operation on and off are simply not an effective enough tool to help shake down code and find bugs that otherwise, I mean, the point is there's no robot available, right? Is what I'm asking about.
My advice is if you can afford a second RoboRio and you have an old robot, try to use that. You're going to have way better success if you can have a second RoboRio and an old robot. I know that a lot of teams can't afford to do that. I know a lot of teams tear their robot apart every year. I would say mini trials, which has come up many times, and Jason's on the call here. Mini trials is a fantastic way to help kids learn real robot programming. And if you can keep that mini trials robot alive through build season, we have kids that were driving our mini trial robots on Saturday because they have already finished all of their code and they can't do any testing until the real robot's built. So they went off and practiced on the mini trial spot.
Yeah, I'll say if you can, you don't necessarily need a whole robot. I know my first year programming on a team, we couldn't afford to have 2 robots, but I was able to get a basic control system and just hold a bag motor in my hand. And I could tell, okay, it's spinning one way and it's spinning the other way. And that was my test board. I eventually expanded it to have 4 bag motors so I could figure out how the heck OmniDrive works that year. But that can be an option.
Well, programming has been prioritized since Cheryl took over the team because we're basically parents of a graduated programmer, and he was put on the last shelf and was actually programming on Thursdays so the robot can run Friday. And we always thought that was just absolutely ridiculous. Programming is a key component to a successful robot, no matter what. And if you only have a few hours to work on it, regardless of all the theoretical code that you could write, it's a pretty big undertaking for these programmers to get something to run correctly in such a short matter. What we had done and talked to one of our sponsors, and they actually sponsored what we call the programming robot. They understand the value of having a programming section that we had created for the team, just not a programmer, but an entire section where we'll have 3-4 kids sitting down. And it's all the FRC components, Rios, and all built into a small FTC chassis. This can actually fit in a little 5-gallon tote. It's cute, compact, has all the components that a FRC robot has, mobile. When the kids are first learning how to program a robot, they get plugged straight in and run and actually see their code work and how well it's working. And also you're able to mount sensors and everything. So the programmers, the regular programmers or our senior programmers still use this to work on sensors, vision tracking. They're perfecting their vision tracking, their Raspberry Pi with it, doing all sorts of little great things. It's rather a huge investment, but it is well worth the investment because this is not something that gets stripped down year after year. It's when you got these freshman programmers coming in, they're learning a whole different thing from the FTC programming to run these things. And we found it just an absolute fantastic tool. They hit the ground running usually. So that's what we do. You just have to bite the bullet. We're not a rich team, so just have to talk one of your sponsors into it or somebody into it that'll just open up a pocketbook. We're using, old motor controllers, the ones that we already had on hand. Make it simple, but the certain components like RoboRio and stuff like that. I think we managed to do it for about $1,000.
Yeah, and to Greg's point, right? I've found that when you have a very specific ask like that, of okay, I need $1,000 for this. Here's what group it's going to impact. Here's how it benefits us towards our overall goals, right? Both competitive and non-competitive. I usually, my rough count is I have to ask 3 people, and somewhere in the first 3 people, I'm going to get a yes out of it. If I can give a very specific goal like that, but I go all over the place to ask. So
I can give you some more tips on how KnightKrawler runs our programming team that may or may not be helpful to you. On KnightKrawler, we have a lot of programmers. In fact, when we started the season, we had more people that wanted to code the robot than build the robot, which is the first time that's ever happened. I think right now we have about a dozen programmers, but in the past we've had as many as 20. So it's a lot. It's hard to keep that many kids busy, which is an opposite problem from a lot of other teams. So what we've done, and has actually worked out really well and can be helpful advice for other teams as well, is we tell the kids that, hey, we're going to write code for every possible subsystem that had been discussed as part of potential prototyping. So we're going to write a subsystem for an elevator and one for an arm. We're going to write a subsystem for an over-the-bumper intake and for an under-the-bumper intake. And we tell the kids up front, your code might get thrown away. But you know what? That's what happens in the real world. We're teaching you how to write code as real programmers do with GitHub and all these other kind of practices that make you good programmers. And this is part of being a real programmer, is sometimes you write code and you either get to throw it away and rewrite it, or you throw it away and you build something else. So we set that expectation up front that you're going to write code, and writing code is good practice. And if we don't end up using your code, that's okay. We'll get you something else to do. And so what that does for us is that we have code to test as soon as the robot gets built. I know that I've talked to other teams in the past, and I think KnightKrawler used to do this a decade ago, where no code got written until the mechanism was there, so we could look at it and we could see how it moves, and then we'll start writing code. We definitely don't wait that long. We start writing code right at day one. I was talking to one of our other programming mentors, and I think there's a good chance we might have all of our subsystems and commands done, not auto, but all of our subsystem commands done by Friday. And now we have to worry about what are we going to have our programmers do until the robot gets built. So I would encourage you to think about coding that way. The other thing you can do, since you can't test it, is if you have an adult who's a professional programmer, that person can help lead code reviews. And a lot of times someone who writes code for a living can look at code and say, okay, we need to do a check here. What if this is 0? We're going to break the robot. Or what if this happens? And so they can lead a code review with the students, and hopefully the students will start to identify, oh, we should check this, or we should check that, or you forgot to add this statement here. And so you can spend a lot of time improving your code without having run it on the robot by doing a whole team, all programming team code review with an adult helping lead that. Somebody who looks at code every day can be good at helping clean up the quality and helping kids find their mistakes.
Scott, have you thought about the kids themselves doing code reviews for each other?
We do that. Our programming captain is responsible for doing all the code reviews, and usually our coding captain will lead these code reviews. For KnightKrawler, that's how we do it. But for teams that are struggling with programming and maybe they don't have any veteran programmers like we do, if you have an adult who can come in, even if they're there just one day a week, I would highly encourage, if your kids have the skill to do code review, you should definitely be having your kids lead those code reviews. 100% for sure. And that's usually what we do on our team.
Yeah, and another thing I want to throw out there, and if this is moving away a little bit, I'm sorry, but from a build perspective, we do two main things. One is that we try to get the drivetrain built as soon as possible. And so if by week 2, if build can have hands off the drivetrain, and that can be programmers, we found success last year that they could just do a ton of auto stuff with that drivetrain. The other thing is, Scott, I heard you talking about sort of communication of getting all those subsystems coded. And one of the tools that we use is a design doc. So we write out what all of our subsystems are, what they all do, and so that sort of helps facilitate conversation between our designers and our coders. And we found a lot of success with that. And that really gets all the data written down where programmers can just look at that and be like, oh, here's how this thing works. But once again, that's from a build perspective, though. So.
Good for you. You're building design docs and requirement docs. That's awesome. That's fantastic. Yeah, great advice.
Yeah, our team also has actually split the robot to where the drive train and the drive base and the electronics are all being built separately from all the mechanisms that they're using and prototyping with. They have the frame and all the electronics in one side, and then in the shop, they have a mock-up of the exact frame that they're going to be using, and is using that to mount the mechanisms on and prototype with. What they're doing, instead of using Neos, they're using good old-fashioned Sims and the old busted cordless drill trick to run the Sims, to make sure everything is lining up and working correctly. And when the drivetrain base is actually done and they have their final build and design for the pickups and everything like that, it will be supposedly, we'll see how this goes, because this is the first time we tried this, be able to transfer everything from the mock-up frame right on directly into the frame. So we have actually two separate departments working on the robot at the exact same time, and they're not climbing on each other. We're hoping this is going to be a little more efficient, a little better, but both sides of that is just killing it. I mean, they're probably 80% done in week one. It's crazy. First time we're way ahead of the curve, we hope.
Yeah, I'll say last year we did similar where we had our arm and intake on. It was a large piece of 6x6 aluminum that was completely separate from the drivetrain, and that allowed the drivers and the programmers to just take the tank drive and run with it while mechanical builds the arm. And then it was 8 bolts, I think it was, to bolt it down. And the really nice thing about that was then in the off season, we had made the decision pretty early on that we wanted to try out Swerve. So we were just able to unbolt this whole arm mechanism from the tank, put it on Swerve, and just go to off seasons with that. And it also was very easy to maintain then.
I mentioned the idea of our alpha robot earlier, and I think the idea of an alpha robot is something that a lot of teams could adopt. You don't have to make it exactly like your regular robot, your in-season robot. It could be, very simplified relative to your robot. Really a drivetrain, an intake, and a camera for vision. Basically a mobile platform for your programmers to work with. I think that solves a lot of problems, a lot of timeline issues that programmers run into. It allows them to work in parallel and get feedback. So I think it's something that a lot of teams could adopt. If people have questions about how we're using our, alpha robot and we're building our schedule for the build season, I'd love to talk to you about it.
One of the things that KnightKrawler has gotten better at the last few years is when the build team sort of hits a roadblock, and I'll use last year as an example, we were having a lot of problems with our 4-bar mechanism that we used to pick up the cones off the floor. And we talked about this in our design group, and we said, Bill's not going to make the deadline to hand it off to programmers. We need more time. And the discussion said, well, what if we give the robot to the programmers right now? It drives, the elevator works, the climber works. Give that to the programmers right now. Let them have it for a week while we work on the issues with the 4-bar, and then we'll take it back. And that was the first time that programmers ever got the robot, I would say, a week early, knowing that they were going to lose it for a week later and then get it back. And the cool part about that is our build team then acted like a pit crew in NASCAR, and they were just waiting on the side of the field. And whenever the programmers tested something, you had to make a change, they ran out on the field and would measure something or take something apart that was non-critical for whatever the programmers were doing. And the programmers would yell, okay, it compiled, we're ready. And so the build kids would back off the field and wait for another window to go do something. And it worked so well. I think we got more time practicing. The programmers got more time practicing on the robot last year than any other year. And that was with the build team hitting issues and roadblocks. But by working together that way and saying, hey, we've got downtime, take it, go use it. And then as soon as there was a little bit of downtime, the other crew would come back. It worked out exceptionally well. And I hope we can build on that for the future years.
Yeah, like this year for us, we've really kind of basically the day after kickoff, decided to adopt the alpha beta robot type concept because we went, okay, we know we could get a mechanism that could get into the amp and the speaker and do ground intake and climb, but we also wanted to be able to do the trap and possibly a buddy climb. And those were going to take a lot longer to design. So we've decided we're going to build a robot that can shoot into the amp, go in the amp, shoot in the speaker, and climb to start off with. We'll have that done into programming in like a week and a half, so they can get working on something that will be at least a robot that has arms and moves. So then they have something to test code on, and we can work on autos, get dry practice, and then work on solving all of the problems and design challenges that come with either doing a trap or buddy climb system.
Yeah, and to Lauren's point, that's that's different than what we've done in the past. We've always had like what we call a practice robot and a competition robot, but they're effectively the same design. So this year we're taking that approach, to have the alpha robot where we're willing to forego the trap, having that in the design to get a robot built and working and handed over to programming and drive in 2 weeks or less. And then it takes the pressure off, and we then have the time to, redesign mechanisms to be able to do that trap.
And I often said that the best strategy for any team is to network with other teams. Week zeros are critical. Get the kids all together. They talk robot all day long. They have little scrimmages running on. You can see and learn how these other teams are kind of going to be playing the game, which is super important, and what you can do to best complement all the other teams. I always suggest week zeros every year, just for that fact.
I have a question. I think something that Sam, I think there are multiple Sams here, but when I raised the point, I think it was about motor burnout during practices. What advice do you have? You make a good point that during the actual competition matches, it's not that much time to overexert your motors, but when you're pushing practice drills, so what advice do you have to prevent that? Because we have very fewer motors. We shifted our resources to the Neo brushless motors, and that's what we're going to be using for the next few years until we get our money's worth out of them. So I'm open for any advice that you got for that, or anyone else.
Overseeing the team,
it was Eric.
as a mentor, you have to tell them take a break here. More than anything else, it's they don't realize how much they're affecting the motors by running continuous practice.
So you still want to set a current limit to that though, and then you're saying maybe schedule your drive practices like here you go, sort of like the match practices, like 2-3 minutes.
Okay. It's not the current limit. See, motors have what's called a peak torque and continuous. Peak is how much you can reach, and that's what your current limit does. Continuous is how long. It's really trying to eliminate raising the temperature. That's what that number comes from, the temperature that you burn out the motor. So even if you set a peak, that doesn't really stop you from burning out a motor from running it continuously. So that really is not a solution.
Something that I would suggest is the battery kind of implements a natural pause point in practices. I mean, you probably won't get more than 30 minutes at best out of a battery, probably closer to 10 to 15. If you can just tell them, when you're swapping out a battery, just touch each motor and see, are they warm? Are they overheating? If they are, it's time to take a break, go take a water break, do something else for a while. If they're not too warm, then keep going.
Is there a certain type of motor that people are burning out? Because I feel like most of our failures, if they burn out, it's user error. Like we stall a 775 or who knows what we do, or we're just using something with the wrong gears.
Pretty much you can burn out anything except a sim.
Yeah, the 775s are very easy to burn out. The Neo 550s, if you leave the default current limit of 80 amps in the Spark Max, will burn out almost immediately. Neos are fairly robust. You still do need, I recommend probably 50 amps if you want to be safe, 60 if you're careful about it. I don't have experience with the Falcon, and obviously nobody here probably has experience with the Krakens or the Vortexes for much duration yet.
The other thing is part of design is that you don't keep anything loaded, meaning that you don't try and hold something up with a motor. And that's sort of unexpected that you're pulling torque out of a motor continuously, even though the thing is just sitting still. But if you have something that has weight on it, that's hanging, that you're trying to hold with a motor, that one you're eventually going to burn out. So that's part of your design.
Not necessarily. So we do use Neos in climber motors. We use them in arms that hold a static position. The key, as Tyler was describing, is setting the current limits so that it can't burn it out and have the mechanical advantage you need. So using a gearbox with a high reduction rate for an arm or a climber so that it doesn't require the level of torque that will burn the motor out. So you can use brushless motors for holding. You just need to be careful that you don't exceed, like Tyler was saying, the 40 amp current rating for the long-term rating, not the default 80 amp. So when we set those current limits, we can use them and hold them for long periods of time and not burn them out. I mean,
Well,
long periods is like 15 or 20 seconds, like you're climbing, right? So if you're doing the end game, you're not holding it for the entire match, like 3 minutes, but you can be holding it.
That's what I'm saying. Some of these on poor designs are held for an entire match, and the designers don't realize that they're holding them. If you're just doing it to do a climb, that's one thing. But if you have just a mechanism, you just have holding up the entire match whenever it's powered, that's something different.
Yeah, I mean, like our arm, we had last year's. We had a very large arm. It was pretty heavy duty, very robust, and we used the Neo motors to lift it and extend it to place cubes and cones. So it was in an extended position for a while as you're picking up elements or dropping them and then retracting down. But yeah, we're not 2.5 minutes, but it could be there for 15 to 30 seconds.
And then again, as in your design, if you've geared things enough, then you're actually applying a fairly low torque on it.
Yeah, we actually made the students do the measurements and look at the torque curves on the motors and calculate how much current it would take based on the weight and forces on the arm. We actually had one of our mechanical engineers make the students do the math and figure out if they would do that. So like we had a double jointed arm, and the bottom part that had the most force, we had 2 motors and gearboxes mounted on the shaft. They were Neo motors with 144 to 1 gearboxes, but sharing the load across 2 of them. And it was able to support an arm that was, 4 feet long and weighed 20 pounds.
We have hit the 8:30 mark. Lauren, is there anything you want to do to wrap things up?
Nothing in particular.
Does anyone have anything that they've been waiting to say this whole meeting and they want to get out before we close things off? All right. Next week, we had somebody sign up. Oh, Mohammed. Mohammed's from 2052. Mohammed's going to talk about drive team selection and how teams are picking their drive teams. So that'll be our topic for next week. There is no one currently signed up to host a topic for January 28th. And we're going to talk about April tags on February 11th. Oh, I'm very excited about that one. That's great. So we still have an open spot for the last week in January. If anyone wants to host a topic for that week, please can sign up. The link is on we created a website, team2052.com/roundtable, and you can get the hosting form for hosting a topic, sign up form for the email, add it to your calendar, see the YouTube link for all the replay videos. This is our 32nd video tonight. So thank you to everyone who keeps coming week in and week out, and to all the new people that have recently joined our conversation. It's been a great run, and we are very happy to have it continue. All right. Thank you again, Lauren. Great job tonight. Good questions. I think you did a great job of spurring the conversation and giving it space to roam around as well. All right. Thank you, everyone. Have a good night.